Welcome once again to another episode physics. All right, isn't optics interesting? All right, I think it's one of the part of physics I love so much. Now we have another question again on optics. All right, let's quickly delve into it. So we've been dealing with lenses for quite some time. Now we have a question of mirror. An object is placed 5 centimeters from the pole of a concave mirror. So today we have a concave mirror. If the focal length of the mirror is 10, what is the image distance? Now, I'll solve this question quickly and I'll show you how to know, all right, if your answer is correct or wrong. Now, the question is quite confusing. How do I mean? We are dealing with a concave mirror, okay? We are dealing with a concave mirror. And by virtue of the structure of a concave mirror, we know that a concave mirror produces real images. Okay, it produces real image, or it produces real images. Okay, a concave mirror produces real images, while a convex mirror produces virtual images. Now, looking at this question, if I want to follow that concept, my answer should either be option A or option B, because real images to be formed in front of the mirror. But don't be deceived. There is a special case in which a concave mirror produces a virtual image. That's the same way we have for convex lens. And that special case is the case that makes it suitable to be used as a shaving mirror. Okay, that means there is one particular case that a concave mirror produces virtual image. That's why I cannot assume that my answer will be option A or option B. Now let's solve quickly. We have the object is placed 5 centimeters. So U is 5 centimeters. Okay, and we have the focal length as 10 centimeters. And I give us a shortcut yesterday. From the mirror equation, 1 over U plus 1 over V equals to 1 over F. Our shortcut is F equals to UV over U plus V. I gave us that in the previous video. Now follow me. Follow me. My F is what? 10. Is equal. My U is what? 5 times V over 5 plus V. Okay, so if we cross multiply, what do we have? We have 10 into 5 plus V equals 5V. Follow me, alright? So we have, this is 50 plus 10V equals 5V. What do we have? 50 equals 5V plus 10 comes to this side. It becomes minus 10V. So we have 50 equals 5V minus 10V minus 5V. Divide both sides by minus 5. What do we have? 5 divide 5. 5 and 1, 5 and 50, we have 10 minus. So we have V to be what? Minus 10 centimeters. I have 210 in my options, okay? I have 210 in my options. So how do I know the exact one to pick? So my answer is either option A or option C. Now because it is negative, you've seen the case of a concave mirror forming a virtual image because of the negative sign. It means the image will be formed at the back of the mirror, behind the mirror. Option C. But for lens, it is formed, the convex lens, for it to produce a virtual image, the image will be formed in front of the lens. But for mirror, for it to be virtual, it will be formed at the back of the mirror. Now, before I end this class, I want to show us diagrammatically how we can know that we are correct. Follow me, just this short diagram. Okay, so what do we have? Let's say this is our mirror. Okay, this is our mirror, our concave mirror. The middle is a pole. Here, our principal focus, and here, our center of curvature. So the length FP is our focal length, and we have 10. So let's say the distance here is 10. So here will be 10 also, meaning P to C is 20, which is our radius of curvature. Don't forget, R is F here to here F, from here to here F. Okay. So we have the object is placed 5 centimeters from the pole. So the middle here should be 5. Okay, so here is 5, and here is 5. Okay, so let's place our object here. So the first procedure, ray of light shines on the object. Follow me please, and then the ray hits the mirror. Okay, when the ray hits the mirror, the first point of passage is the principal focus. So it passes through the principal focus. Alright? Then after passing through the principal focus, we also pass through the center of curvature. Looking at these two rays, they can't meet here. So the image cannot be formed in front of the mirror. So the image will be formed where both rays meet at the back of the mirror. Hope you can see the diagram. So this is where the image, this is object O, this is image I. What do we see from this? This is one of the reasons why the concave mirror is used as a shaping mirror. Why? The first reason, it produces a magnified image. Magnified image. When you're using a shaping mirror, your face is enlarged. Alright, a magnified or an enlarged image. You can shape well for those guys, alright, that have, what I'm talking about. They understand what I'm talking about. Alright, so you have a magnified image. You also have an erect image. You're not seen upside down in your face. Erect. Alright, an erect image, and you have the image is formed behind the mirror, making it a virtual image. Okay, so this is a special case of a concave mirror forming a virtual image. As the object goes close to the mirror, the image will be formed behind. So that is why option C is correct. So you have validated our answer. So please like and share and follow for more interesting videos on optics. Thank you very much.